Hello and welcome to day 2 of MIDL 21. It's prime time again. I'd like to say hi to everybody and also have a few announcements from what we've learned from yesterday and what we will do today. So from looking at what happened yesterday, we are quite happy that everybody interacted quite a bit, and we would like to see that again today. I would like to encourage you to be active on GatherTown again or in GatherTown again. And also I have an announcement to our short oral presentations or the presenters there, where we've noticed that it took a bit of time to share the screen, and we would like to ask you not to share your own screen, but to take the slides that we provide and spend most of the time discussing the presentations. And also to all of you, please keep in mind that there is the Proster room, that there are more discussions possible, and go there and use that opportunity. Also, I would right now, even though it's quite early still here in Lübeck, like to remind you that tonight there is a big gala event, and you should keep that on your schedule or in your schedule and be there as well. But before we get there, we would like to start the program for today, and the program for today starts with our sponsor session, and I'm handing over to Matthias for the sponsor session. Thank you.
Hi everyone. Tiemen Blankefort. I hope I pronounced this more or less correctly. And we're looking forward to your presentation.
Yes, thank you. Let me get this started. Wait, I have to unmute myself, I think. Give me 1 second. Am I unmuted?
We can hear you.
Okay. Oh, you can hear me? Good, great, awesome. Can you also see the presentation? Is this working?
It is slightly smaller than expected.
Is he full screen now?
Now we see the presenter mode.
Ah, okay. How are we going to fix that one? Swap displays.
Yes.
Better?
Excellent.
Great, great. Okay, hello everyone. My name is Tiemen Blankefort, and I'm here representing Qualcomm AI Research. So you might ask, what is Qualcomm? So Qualcomm is essentially anytime you see a 4 or 5G signal on your mobile phone, it's a very high likelihood that there's Qualcomm technology behind that. But even bigger is our chip business. So Qualcomm makes a lot of chips for many, many devices in the world. So you can run into any random phone store and look at the top-end devices probably that you're using nowadays. And it's a very high likelihood that there's some kind of Qualcomm technology or Qualcomm chip in there. And of course, nowadays, AI is everywhere, so you need to be able to run your AI networks on mobile phones. For example, to do object detection, recognizing an elephant, like in this picture. But Qualcomm does a lot more than just mobile phone chips. Of course, smartphones are a big business, but we also have a lot of IoT applications in smart homes, smart factories, and smart cities that have Qualcomm chips in them. A lot of the extended reality or augmented reality or virtual reality goggles have Qualcomm chips in them. We also sell a lot of things to autonomous vehicle manufacturers. So really, the products that we're making are going into many places. And all of these things need to be smart in the future. And one of the big things we also see is that AI video analytics is on the rise. So a lot more mobile phones are running deep learning workloads and videos, which are incredibly expensive, but we still want to be able to run those on these tiny devices. So that's one of the big things that Qualcomm AI Research does. We're making a lot of advancements in artificial intelligence to make efficient AI ubiquitous. We want to make sure that every deep learning network in the world can actually run on many of the applications and devices that we're using today. So what are we doing? Among a lot of other things, we're looking into things like power efficiency. How actually do you run these things power efficiently on device? Can you compress your networks? Can we quantize them to get a lot of energy benefits? But also things like personalization, right? You want to be able to update your neural networks on your phone. Anytime your voice activation makes a mistake, you want to be able to fix that, right? That it recognizes your phone, especially, for example, if it has a Dutch accent like I do, and it has to be able to recognize that. But also things like distributed learning, coupling multiple phones to each other to actually do the learning itself, and efficient learning. Like how can we do learning in a robust fashion with minimal data? Because of course, if you have customers interacting with your phones or your devices, they're not going to stick around for 5 days to label all your data. So you have to be very efficient with that. So we also do a lot of work in perception, and let me just highlight one thing from the video perception effort that we're doing. So if you're running video networks, you can actually make them more efficient in many ways. And two of the ways that we have a lot of papers in is, for example, using temporal redundancy. So you can actually learn how to skip certain regions in your picture. So air pixels might not need processing of semantic segmentation every frame, right? You can skip for a few frames until you've seen that there's something changing there. And you can also recycle features and learn how to do so in a smart way. So that's kind of cool research that we're doing, that we have some publications on at the moment. And also things like early decision making. So if you do action recognition on video in a phone, you might not need all of the frames and look at all of the frames, and only some of the key frames are important. And that's something you can learn. But also early exiting, like if you have a network that's running to do some kind of classification, for very complex examples, you might need to do a lot of compute. But for some very simple images, you might not need all of the neural network layers, and we have some ways to actually learn that. Now there's research happening in this area, but we're also running these things in practice, which is I think quite cool. And let's hope this video works. So here what you see is our EVSNet, which is from a CVPR paper of this year, running on a mobile phone. And a bigger version of this network is actually state-of-the-art on the Cityscape semantic segmentation dataset. So it's one of the best networks in the world. And it runs essentially real-time on a phone. It's on a Snapdragon 888 platform. And it's like 3 times faster than if you were to take like a other state-of-the-art network that's pretty fast, like an HRNet. And we also reduce the memory consumption by a factor 9 or something like that. So we both do the research in this area to make these things happen and get state-of-the-art papers out, but we also run these things on actual phones, which I think is incredibly cool. Another thing that we're quite big in is neural network quantization. So if you want to make your neural networks more efficient on device, quantization is one of the best ways to do so. So if you train your neural networks on, let's say, a GPU, you might run you run them in 32 bits or nowadays 16 bits. But if you can actually go down to, let's say, 8 bits or 4 bits, you get a lot more efficiency. So 32 bits compared to 8 bits is a 16 times speed up in terms of performance and memory savings and efficiency, like power efficiency. And if you can take some of your neural network layers and get those to 64 bits, like 4 bits, it's going to be a 64 times speed up. There's a lot of papers we have in this area. There we go. So one of the highlights is, for example, the data-free quantization paper, where we actually, without doing any effort on the side of the user, allow people to deploy their networks in 8 bits better. And a more recent paper is called ADA round, which is really cool. So there's this long-standing assumption that rounding to nearest is like the best thing you can do for quantization. And we challenged that assumption and wrote a quite technical, fun mathematical paper on how to actually learn the rounding and how to do that better. And then you can actually, turns out you can do a lot of your network in 4 bits as well. So you can actually get pretty close to that 64 times speed up compared to the original 32-bit network. So many of these optimization tools we actually released in a model toolkit called AMET, and it makes AI models small. And the idea is you can come with any of your PyTorch networks or TensorFlow networks, and then you can compress them, make them smaller, quantize them, and optimize them for on-device deployment. And then you get a PyTorch or TensorFlow model back, and you can deploy that to any device that you want. And one of the really cool things about this toolkit is that it's actually being used by many of our customers to deploy their neural networks more efficiently, and it's developed in a very professional way. So it's very high quality software that's very robust and works in many situations. So if you're interested in this, please download it from GitHub, completely free and open source, available. Now going a little bit beyond like vision and videos, there's also a lot of other cool modalities that we do computer vision on. For example, one of them is fingerprint scans. For fingerprint scans, we have a device that actually uses kind of like small Wi-Fi signals to recognize your fingerprint. And that can actually work through like a glove, or if your finger is wet, for example. So perhaps in the future, you're actually going to have phones where you can actually keep your gloves on in some situations and still open your phone with a fingerprint scan, which I think is pretty cool. And another thing is that I'm very excited about is RF sensing, and I have a little bit of a video on this. So what RF sensing is about is essentially you have a lot of Wi-Fi points in your house, right? And these are called APs or access points. You can actually use that Wi-Fi signal to detect where you are in your house. So we made an app where you can just say, okay, I'm walking in the living room at the moment. And then you walk through your living room, and then it learns that that is your living room. And this is kind of like done in a semi-supervised fashion. So you labeled it a little bit with this app. And now it knows anytime you're walking there, or you're walking in your kitchen, or you're walking in your garage, it now knows that that's exactly where you're walking. And by doing so, without using any sensors, without using any cameras, or without using any other infrared detectors or whatever, just by using the wireless points that everybody has in their house, we train a deep learning neural network to actually do this detection for you. So in a semi-supervised fashion, you only have to give it a few labels of these rooms. Anywhere you go in those rooms, it will be able to detect you at a very high accuracy. And of course, in the future, this is going to enable things like smart home applications for everybody. I mean, everybody has a wireless router, right? So lights turning on automatically in your house, for example, or perhaps the room temperature changing based on where you are. These are things that we can enable for anybody through kind of technology like this. I think this is really exciting. So we do a lot of computer vision research, but there's also a lot of other things going on, both from the applied side to the fundamental research. We also have teams working on voice recognition and applications there. We have people working on source compression, like compressing compressing with neural networks videos and images on a phone. From all the way to the fundamental research. So we also have people working on quantum artificial intelligence, and we've published a few papers there. So that's really the future of AI, in my opinion, doing this all in a quantum fashion. But also things like group CNNs that I have a little example for. So group CNNs are essentially a way to implement invariance into your network. So for example, if you have these histology slides, we know that it doesn't matter if you're rotating 30 degrees or 50 degrees or 90 degrees. Your predictions should stay the same, right? Because the data is invariant to rotations. So we've done a lot of research in the last 5 years or so into making neural networks invariant to many things, also on spheres and on other things. But this 2D invariance is really great for medical applications. And of course, what you want, if you start rotating this image that you see here, you want the predictions that you see. So the green is accurate, and then the yellow and the red is not accurate. But you want these predictions to stay stable over time. And that's what these group equivariant neural networks, these group CNNs actually do. And this is also just running in real time on a phone. It just makes the prediction stable to rotations. Now you can actually try to do that in another neural network, using a normal neural network, and you can train it with rotation invariance and rotation enhancements, but you don't really get the property that we see here. And by actually baking in the invariance into the neural networks, you get both better performance, and the performance is very stable over time. So this is basically the kind of thing that we're doing in the medical area as well, enabling these kinds of new technologies running on phones. So if you're excited about this, just as excited as I am, and as I seem to be at this moment, we are most definitely recruiting. So we have locations in San Diego, in sunny Amsterdam, where I am, and in Korea. And if you're interested, just Google Qualcomm Deep Learning Researcher, apply, and I really hope to see your CV in our mailbox tomorrow or today. Thank you all for listening, and I hope you enjoy the rest of the conference.
Thank you, Cayman. There was a little question in the chat. You showed just one application in medical imaging or biological imaging. Could you elaborate if there's anything else you plan to do in medical imaging?
So I'm more in the research direction. So we work on a lot of applications, but we are not working on medical imaging directly by ourselves. But there are a lot of chips being used in medical devices that are also Qualcomm based. So myself, we're not working on a lot of applications in medical in the Qualcomm AI research department, but somewhere in Qualcomm people are doing that. So if you want to join Qualcomm, I guess you shouldn't do it for the medical image applications, but more just for the other amazing cool applications that we enable.
Yeah, thank you so much. It was an amazing talk. And now we move on to our last sponsor, which is a video by BioMedTech. And afterwards, we directly go into the first long oral session. So stay with us.
Change. When it driving change. BioMedTech Science Campus Lübeck. Welcome to the BioMedTech Science Campus Lübeck in the federal state Schleswig-Holstein. Close to the Baltic Sea, you can find an excellent and rare science landscape consisting of the University of Lübeck, the University of Applied Science Lübeck, the University Hospital, Fraunhofer Research Institution for Individualized and Cell-Based Medical Engineering, and the Leibniz Center, Borstel. We are an interdisciplinary, innovative campus, all close together and connected. The campus covers the entire chain from basic research to applied research and clinic to market. The establishment of the Artificial Intelligence Center was another important step for research at the campus. I am pleased to welcome Professor Martinez, Director of the Center. What is the focus of the Artificial Intelligence Center and what goals are you pursuing with it?
The University of Lübeck has a long tradition in medicine, but also has a very strong computer science department. And for a long time now, we have been active in artificial intelligence in connection with medicine. So 2 years ago, we established the center where now institutes from the computer science in basic research, applied colleagues, and also the colleagues from the medical faculty are now under one umbrella, and the center now consists of 34 institutes and clinics, half from the computer science, but also the other half from the medical faculty. And our goal is to bring these two most important parts of the university together and to foster innovations and research projects. And now we already have a couple of very big research projects funded by the federal government, German federal government, and also funded by the state. So it was a very good start, and I think there will be a lot which will come out from that.
What kind of project?
These are mainly projects. For instance, we have one big project where different topics are covered, but it's all medical and artificial intelligence coming together, for instance, in radiology or in neurosurgery, and companies are involved, big companies, smaller companies. So we now are establishing a whole ecosystem for medical applications of artificial intelligence, where different steps are covered, like methods, like the data problem we have in artificial intelligence, regulations are covered.
Okay.
So we all learn together these different aspects which are important for artificial intelligence in general, but in particular also these special applications in the medical domain.
Okay. Is the AI Center also open to companies? It sounds like this because you just told us. And how is your collaboration with industry? How welcome in the alliance?
Very welcome, of course. And we have a couple of projects already. We are offering infrastructure for industry, like special purpose AI software and special purpose AI hardware, which can be used also by industry partners.
Oh, okay.
And of course, we are very eager to bound companies. We have a very strong medical technology company ecosystem in the north of Germany, and we offer these know-how and these different instruments for the companies to learn from it and also to somehow profit from it.
Okay. So companies, you should phone him. Mr. Martinez, you are also the director of the Institute of Neuro and Bioinformatics at the University of Lübeck. How important is deep learning in imaging, and what research are you currently working on?
So our institute is interested in how the information processing is done in biology and in particular also in the brain. And this is a field which has gained a lot in the last 20 years, and we have learned a lot in the last 20 years. And one of it are these deep networks, which are from the structural viewpoint are close to what is used in the brain by the neural networks we have there. And in the last 10 years, there was a huge step forward by making these networks deeper and larger, and the hardware development supported it, and also the big data which is needed to train these networks. And this was a quantum loop in image processing. Many tasks which were difficult in the past now can be solved. And this is not only in image processing, the same is also in language, natural language processing, where we have made very, very deep and very large progress compared to 10 years ago. And but still, there's a lot we can learn from the brain. These networks are able to solve certain tasks, but they are not really intelligent in the sense our brain now is still able to bring out intelligence, and there's still a lot we have to learn to make artificial systems really intelligent.
Oh, that sounds very interesting. Thank you very much for answering our questions, and good luck for all your ideas and projects you are working on. Thank you very much.
Thank you.
I would like to welcome another interview guest. Welcome, Nele Blum. You are research assistant at the Institute of Medical Engineering at the University of Lübeck, and you are doing research in the field of medical imaging. What is your background? And what exactly you want to find out? And which role plays artificial intelligence in that context?
Hello, and thank you for having me. I studied medical engineering at the University of Lübeck, and doing my master's degree I spent 1 year in Kiel at the company Stryker, where I also did my master's thesis about 3D puzzle algorithm and rearranging 3D bone fragments. Afterwards, I started as a research associate and as a PhD student to make my thesis also. And there I researched mainly on computer tomography in the field of image reconstruction and mainly in the field of reducing meta artifacts. Yes, AI plays a role whenever our standard approaches reach the limit due to when we have like limited data of physical limitations. And for meta artifacts, for example, when meta objects, we have projections that are corrupted by these high density objects, and so we have a loss of information. And this loss of information is especially the case when we have low radiation doses. And this, on the other hand, is of course good for the patient. So we have like a compromise of radiation dose and a good image quality. And there's where we can use AI. And another aspect is, of course, that we have an increased number of databases which are being created, and also we have an increased computational power, so we are able to use these networks on our problems.
Okay. What goal are you pursuing with your research?
Yeah, I try to reduce artifacts in the image mainly, so we want to have an image with low noise, no patient movements, and less meta artifacts. And also for meta objects, again, we have the problem when we have like diseases or tumors which are close to the meta object that we want to detect them. And when we have these artifacts, it's not often not possible. So we try to use here enhanced image reconstruction and use also new methods like deep learning to get rid of these artifacts.
Okay. And what are you doing to take part in alliance research?
In computer tomography, we are able to visualize the inner structures of different objects. And this is not only the case for clinical applications, but also for industrial applications. So here we already work with different industrial partners. And of course, we want to have new cooperations as well. And another aspect is that we also can transfer our current knowledge in algorithms and optimization strategies, and of course also especially AI, to other fields of interest. So not only the field of image reconstruction, but also like image processing. And I think this is something we can do, and I hope that we find new cooperations.